Okay, Algebra 1, this is Chapter 3, test review. Question number 1. How many spaces are there in the answer column for question number 1? Two. So guess how many answers there are? Possibly 2. So always remember that this book company is not very, they don't try to hide things. If they've left 2 spaces for you, then there's going to be 2 answers. Question number 1, determine whether it's a function, and if it is, if it's linear or not. How do I determine if something's a function if they give me a table like number 1? Incorrect. That is slope, and that's on the back page, but we're getting there. Remember that one.
Don't you find the interval between,
That's to see if it's linear. We're not there yet. Okay, so that's linear, so I'm going to go ahead and answer this one so we can move on, okay? If it's a function, in number 1, all x values are different. Okay, so the very first thing is I look at all the x values, 1, 3, 5, 7. Are they all different? Yes. So is this a function? Yes, it is. Now, the second question, and notice it asks if it's linear or nonlinear. So the second part of your question is not a yes-no answer. It's linear or nonlinear. Now we look for patterns. How do I get from 1 to 3 in my x values? Add 2. How do I get from 3 to 5? Plus 2. How do I get from 5 to 7? Plus 2. So right now it's linear. Let's go to the y values. 4 to 6. Plus 2. 6 to 8. Plus 2. 8 to 6. Minus 2. So did it stay consistent all the way across? It did not. So this is non-linear. Now, when I say consistent, does that mean my x's had to be plus 2 and my y's had to be plus 2? No. Y's could have been plus 4, but if they were all plus 4 all the way across, that would be okay. They don't have to match top and bottom. They just have to be consistent. Question number 2. If I have y equals 3, that's a very specific line. Y only. What kind of line is that? That is a horizontal line. Okay? Now, because I don't have a table, I can't necessarily look at values, but if I have a horizontal line, there was another test I could do to see if it was a function. What was that test? The vertical line test. If I run a vertical line across a horizontal line, it will only intersect at one point at a time. Do you agree?
Yes.
So that makes this one a function. Horizontal lines are always functions. What kind of line is never a function? The vertical line, okay? So be ready for that. You see a horizontal today, maybe on the test it's vertical. I don't know. Maybe they put one of each. Who knows? Okay, so obviously if it's a horizontal line, is this linear? Yes. So this is, yes, it's a function, and it's linear. Question number 3. I would advise you, if you get one of these tomorrow, to actually put the coordinates. Okay, so my coordinates for this one are 1, 3, 1, 6, and 5, 8. The reason I would ask you to put those down is because some of you will look at the inputs and you'll say, oh, all the x's are different. But you'll forget that they can put 2 arrows off of that 1, and that means it's listed twice. So, is this a function? No. Why not? Because the x's repeat, okay? So this is not a function. And in the directions it says if it's not a function, you don't have to say if it's linear or not. So we don't have to answer any more on number 3. Okay, question number 4. Okay, is it a function of x? Could I graph that? Could that be a line? Let's say x was 5. What's 5 over 5? 1, and what's 1 plus 7? 8. Could I graph y equals 8? Yeah, it'd be what kind of line? horizontal. So this is a horizontal line because it's y equals something. However, okay, let me start with that. The first one was it a function? And that's the horrible y, but that's okay. Okay, it is a function. Now it asks what the domain is. Is there any x value that I could plug in there that would make that thing not a function? There's a forbidden number in the denominator that it can never be. What is that? 0. I can never have a 0 in my denominator. So the domain for this would be all real numbers, except it cannot be 0. So it can be anything but 0. If I put a 0 in there and that makes that 5 over 0 plus 7, 5 over 0 is not a value. It doesn't have value, so I can't add it to 7. But I can put any other number in there and it will work. Question number 5. What kind of number could I put in for x? 4? What's another one? 5, 8, 17, 362,147.5? Absolutely. I could put that one in there, right? Can I get a 0 on the top? Could I put a -8 in there where it's -8 plus 8, and that gives me 0 over 3? Is that a possibility? Yes, I can have a 0 in my numerator. I just can't have it in my denominator. So this is, by the way, a function. But the domain for this is actually all real numbers. I can put anything in there. It doesn't matter. And number 6. What if x was 0? What's 2 minus 0? 2. Okay, what's the square root of 2? Yeah, 1 point something, whatever it is. Could I graph y equals 1 point something?
Yeah.
Sure, yeah. What if x was 5? What's 2 minus 5? -3. What's the square root of -3? Crickets. They're so quiet right now. Those of you who are listening on the screencast, this is the quietest my 6th hour has ever been in history. Why can't I take the square root of a negative number? Haha. Okay, so we can't take a square root of a negative number yet. When you get into Algebra 2, you will learn about imaginary numbers. But right now, in your Algebra 1 time frame, we can't take the square root of a negative number. However, there are some numbers that will work. What is the first number that will cause that square root bracket to be negative? 3, because 2 minus 3 would be -1, right? So this could be all real numbers except x has to be less than or equal to 2. I was trying to figure it has to be less than or equal to 2. Okay. Could be 2, because 2 minus 2 is 0, and I can take square root of 0. All right, it just can't be anything less than 2. Is that right? That doesn't look right for some reason. Yeah, x has to be less than 2. X can't be greater than 2. So it has to be less than 2. Yeah. I'm sorry. I'm just having a moment here. Having a senior moment. It's okay. I'm an old guy. Plus or minus is just, it could be plus or negative. Yeah, if this came out to be 0, there's our good friend -0 again. That's fine. If this came out to be 4, then square root of 4 is 2. It'd be plus or minus 2. That's fine. Awesome. Okay. Number 7. Number 7, I don't need to graph. It's already been graphed for you. Okay, find the domain and range of this function. Okay, number 7, the domain. Okay, it stretches on forever. What can I plug in for x values? Anything, all real numbers. However, the range actually stops. How low does it get on the y-axis? 0. So what does my range have to be? Greater than or equal to 0. Remember, it's y values greater than or equal to 0. Now, do you see the difference between 7 and 8? 7 stretches on forever to the right and left. 8 is 4 very specific points. So I would label them, and they are going to be -2, -1, -1, 3, 0, -2, and 3, 0. Very specific endpoints. So our domain or range will never be all real numbers on something like this because it actually has values. How do I list domain and range values? It's a very specific way to list them. What do you think? Least to greatest. Perfect. So the domain, in this case, and I'm just going to kind of speed it up. They're already in order. I put them that way because I can. And I want to make sure we get to all the problems today. Okay, the domain is -2, -1, 0, and 3. Also, when you list them in order from least to greatest, if one repeats, do I put it in the list twice? No. I do not. So you list each number specifically only one time. And what's my range? Anybody got that already? Anybody figured that one out yet? What do we got? Will, what do we got? Yep. Yep. Ah, it's the same thing. Okay, they actually came out to be the same values. Probably a coincidence, so I wouldn't look at number 8 tomorrow and go, oh, they're probably all the same. Okay, don't try to draw that conclusion. Okay, number 9. Number 9, 10, and 11 are going to have how many answers? 3 answers each. Okay, so I'm going to take the next 5 minutes and I want you to solve 9, 10, and 11 by substitution and get me all of those answers. Okay, ready, go. Okay, so on 9, 10, and 11, the things that are going to get us the most times are math. Plugging something wrong into the calculator. I want to find -1 squared, and I plug that into my calculator, and it says -1 because that's the way I entered it. I didn't enter it as -1 times -1, and so the calculator didn't read it the correct way because the user had a little bit of error on it. Okay, so be very careful also with PEMDAS. So let's look at the first one. So I'm going to take 3 times -1 squared plus 1. What do I do first according to PEMDAS? The exponent. What's -1 squared? That's 1. What is 3 times 1? 3. What is 3 plus 1? 4. All right. 0 is my good friend when I multiply because it cancels out all of this junk and all I'm left with is 1. Okay. The last one is going to be 3 times 4 squared plus 1. Which one do I do first? The 4 squared. 4 squared is 16. 16 times 3, 48 plus 1, 49. Okay, how many got all 3 of those? How many got 2 out of 3? Okay, and I'll stop there. We'll do better on the next one. Number 10, I've got -2 times -1 minus 4. What's -2 times -1? +2 minus 4? -2. Again, zeros cancel out everything there, so all I have left is that -4. And then in the last one, I've got negative 2 times 4 minus 4. Negative 2 times 4 is negative 8. Negative 8 minus 4? Negative 12. How many got all three of those right? How many got 2 out of 3? All right. Number 11. A little more intense. Now we add the absolute value to it. Remember, don't take absolute value until the end. So the first one, I'm taking negative my x value. I'm adding 5 to it, and then I take the absolute value bracket, or absolute value of. What's negative a negative 1? Positive 1. What is 1 plus 5? 6. What's the absolute value of 6? 6. Zeros help me out again. What's 0 plus 5? 5. What's the absolute value of 5? 5. I love that 0. He helps me all the time. Last one is the absolute value of negative 4 plus 5. What's negative 4 plus 5? Positive 1. What's the absolute value of 1? 1. How many got all three of those? How many got 2 out of 3? All right. Number 12. What does f of x equal? 3. No. Y. I'm just saying in general. F of x, it's a function of y. Okay? So what it's saying is, where y is 3, what is my x value? So let's look on that line. Go up that line and put a pencil point or a dot or a coordinate when it gets to y equals 3, and then tell me what the x coordinate is. What is it?
2.
It's 2. Okay? So go up the diagonal line until your coordinate has a y value of 3, and then find out what the x coordinate is. These two questions tomorrow should take you about 5 seconds. Okay? Oh, I got to go to where y is 3. Boom. X is 2. Move on. Number 13. And number 13, I go down the diagonal line or up, depending on which way you're looking at it, to where y is negative, or where y is positive 3, excuse me. And what's my x value on that one? 1. Okay. 14, 15, and 16. Finding slope, finding x-intercept, finding y-intercept. Notice that all three of them are in different forms. Okay? The first one is standard form, number 14. Number 15 is slope-intercept form. And then 16 is just a vertical line. So we'll get to that in just a minute. So if I have 5x plus 3y equals 15, how can I find the x and y intercepts? Let me ask this question. How can I find the x-intercept? Owen. Say it. Let's even just do better than that. Let's just get rid of the 3y. Let's just pretend it's not there, because that's what 0 is going to do, right? That's what I put on the screencast. He's telling the steps that were on the screencast. But what happens is it just goes away. So I know you can't see this at home on the screencast, but right now I'm covering up the 3y. So I just get 5x equals 15. So what's my x-intercept? 3. I divide both sides by 3, or by 5, excuse me, and get a value of 3. How do you think I'm going to find the y-intercept? Get rid of the 5x, right? So now I've just got 3y equals 15. What's my y-intercept? 5. Those are the easiest ones to get out of the equation. The slope is a little more difficult, but not too bad. 2 ways I could do it. I could go on the x-axis and put a point on 3 on my graph paper, and I could go on the y-axis and put a point on 5, and I could do rise over run. Okay, if you're more of a visual person, you might want to do rise over run. Or, if I could put this in y equals mx plus b form, the number that's in front of the x would be my slope. If I could put it in that form. Can I put that one in that form? Of course you can, because we've done chapters upon chapters of manipulating equations and getting y by itself, right? So what's the first thing I would do if I wanted to get y by itself? Move the 5x by, how would I do it?
You would
Subtract 5x. So I've got 3y equals negative 5x plus 15. I just subtracted the 5x to the other side, made it negative. Okay? Now if I want to get the y by itself, what do? Divide everything by 3. Now, all we need is the slope. So what's the number out in front of the x? Negative 5 over 3, right? So negative 5/3. So the slope is negative 5/3. Now, if you kept going, what's 15 divided by 3? 5, and that should be the y-intercept, right? Boom, it is. It's magic. Doesn't matter how you do it, there's multiple ways. Oh, 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 it's magic, you know. All right, number 15. Oh, number 15 is in slope-intercept form. So I can find the slope and the y-intercept quickly. What's the number out in front of the x? 1. So what's my slope? 1. Shh. What's my y-intercept? No, it's negative 3. Remember, if this is slope-intercept form, the number that's by itself is the y-intercept. Now, this is the one that's a little bit more difficult to find. Now I got to find the x-intercept. Well, on that one we just previously did, the x and y's were on the same side. On the one we're doing now, the x and y's aren't on the same side. Could they be? Yep. How could I get that 1x to the other side? Subtract it. So wouldn't this look like y minus x equals negative 3? And if I want to get the x-intercept, what do? Get rid of the y, right? So I get negative x equals negative 3. Obviously, I don't want negative x. I want positive x. So what does positive x equal? Positive 3. So my x-intercept is 3. Now, the last one I'm going to graph, and there's a reason. This is number 16. How do I graph x equals negative 4? What kind of line is it? It's a vertical line, okay? So it's a vertical line through x equals negative 4. The reason I graph this, I show this a little more visual, is because now I can get all of that information just from this graph. I don't have to manipulate anything or do anything else. What's the slope of a vertical line? Undefined, or no slope. Again, you don't have to put both, just one or the other will work. I accept either one, I don't care. Okay, undefined or no slope. What's the x-intercept? Hits the x-axis at negative 4, right? Good. Now, here's the trick question of the day. What's the y-intercept? There's not one. Okay, this will never hit the y-axis. Even in a parallel universe, it still won't. Okay, so the y-intercept is none. Ain't got none. Ain't gonna happen. No way is this happening, my man, my woman, my students. Okay. Is there a vertical line? Shh. Is there a vertical line that does hit the y-axis? One that's on the y-axis, right? So that would be x equals what? 0. If you had to plot the line x equals 0, that would be a vertical line that is literally the y-axis. So would it have an x-intercept? Yes, at 0. Would it have a y-intercept? Yes, at 0. It's the only one that has a y-intercept. The only vertical line that has a y-intercept. Okay. Okay, number 17. 17 and 18 have to do with the slope formula. Okay, this is something you'll have to have memorized for tomorrow. Who can tell me what the slope formula is? Perfect. y2 minus y1 over x2 minus x1. That means y value of my second coordinate minus the y value of my first coordinate over et cetera, et cetera. So I need 2 coordinates. Well, this table gives me 4. Which ones can I pick? Doesn't matter. Okay, pick whichever ones you want to. Okay, I like to pick the ones that don't have negative values in them, but in this case, all 4 of them have negative values in them, so it doesn't matter. I'm going to pick the first ones. I have -5 and 7, and I have -3 and 4. What's the y value of the second coordinate that I picked? 4. What's the y value of the first coordinate that I picked? 7. Okay. What's the x value of the second coordinate? -3, and I'm going to subtract from that. Be careful here. This is where you have to watch your signs. I'm going to subtract the x value of my first coordinate, which is what? -5. So I'm going to put that in parentheses because I got that double negative down there. What is 4 minus 7? -3. What does, again, I'm not asking for a number answer, what does -3 minus a -5 mean? Add 5. So what is -3 plus 5? +2. So my slope is -3 halves. Don't change it to -1 1/2. Don't make it a decimal. Leave it as -3 over 2. That's rise over run. That's exactly what we want. Number 18. Here's a news flash. In number 18, something's the same all the way across. What is it? The x. My x value is always 2. What kind of line is that? It's vertical. I already know what the slope of a vertical line is. I don't have to use the formula. What's the slope of a vertical line? Undefined or no slope. Don't make the mistake of tomorrow, if you get one like this, and letting your answer be vertical line. Because vertical line doesn't tell me what the slope is. If they ask what the slope, I need to see this. Okay, number 19. And these are graphs. I want these done on graph paper, please. Even though there's a little space on the worksheet, I want them done on a separate sheet of graph paper. So I have x minus 3y equals 6. Just a couple of minutes ago, when x and y are on the same side, we found it really easy to find what? The x and y intercepts. How can I find that x-intercept? Cover up the y. So what's my x-intercept? 6. Okay, I'm going to slow down for just a second while some of you are finishing. Okay, so now we want to find the y-intercept. So I'm going to cover up the x, and I get -3y equals 6. So what's my y-intercept? -2. So on the y-axis, I go to -2. Do I have enough points to make a line?
Yep.
Sure do. Okay, so remember, don't graph a line segment. Okay, oh, that was a horrible graph. Make sure that you put your arrows at the end. That'll be the first thing I look for when I grade the test tomorrow. Well, tomorrow for certain hours. Is that all it wanted us to do? Yep, just graph it. Awesome. Hey, guess what number 20 is? It's a graph. Woo! It's in a little bit different form. Whoop. Graphs are fun. They are time consuming. I would agree with that. So what form is that? Y equals mx plus b, which is what? What's it actually called? Slope-intercept form. So I have two values I get there. I can get the slope and I can get the y-intercept. Which one is the y-intercept? The 1. So I go up on the y-axis and I put a point. Now, I'm going to bring down the next one, which it's the slope. What are the two words that we use to represent slope? Rise over run. So I'm going to rise and run from where? From where? This is where some of us struggle. We know what rise over run is, but we're not sure where to start. From where? Which point? There's a bunch of points up there. The y-intercept that we just put up there, right? We put that point for a reason. That's our starting point. So if I'm going to rise in a -2 direction, what does that mean? You're going to fall 2 positions. So I'm going to go down 2. And then if I run in a +3 direction, what does that mean? Go to the right. So I'm going to go down 2 and to the right 3. Okay, now just to make a little magic here and show you that it doesn't matter if the negative is on the 2 or on the 3. Let's say the negative was on the 3. So I would rise 2 and run 3 to the negative direction. And it's the same line. It doesn't matter. So it doesn't matter where your negative sign is on that 2 or 3, but it can't be on both of them. It can only be on one of them. Confused where? I heard I'm confused. -2 over 3 and 2 over -3 are the exact same value. So what I did here is I went down 2 over 3, and what I did here was I went up 2 and to the left 3. Does that make sense? Okay. All right, so that gets that graph. Now let's move on to transformations. Okay, number 21, not a whole lot to write on number 21. We don't really need to concentrate on the actual equations. Let's just look at the lines. There's two things this line can do, okay? It can either move left or right, or it can move up or down. Okay, now the key here is, since I have two lines, am I looking at the transformation from G to X, or excuse me, from G to F, or am I looking at the transformation from F to G? F to G. So I'm looking at the right one. How does it, the one on the right, how does it get to the one on the left? It actually can do two different things. Does anybody see one of them? What does it do? It could move up 3. Okay, so vertical shift up. I agree with that one. What's another thing it could do? It could also go to the left 3. So either way, moving the one from the right to the left or moving it up, either one of those answers is fine, and I would accept both of them. Okay, now 22, this is where we have to put our reverse hat on. Okay, if we take that function, negative x plus 5, and we multiply it by 2, two things could happen. It could shrink or it could expand. If we multiply it by 2, what's it going to do? It's going to shrink. This is the one where it's backwards. When I multiply by a whole number, it actually shrinks, which doesn't make logical sense to us, right? If I have 2 pizzas and then I multiply them by 3, I should have 6 pizzas. Okay, but 6 pizzas are not a line function transformation. Okay, so pizzas are much more delicious than line transfer functions, transformation thingy jiggers. I just want to eat some pizza now. Okay, if I multiply by a fraction, okay, it actually expands. Okay, if that were 1/2, it would actually expand by a factor of 2. Okay, again, it's just function notation. It is what it is. Number 23. I think 23 we're going to have to graph, aren't we? Yep. Yeah, 22 just, no. It shrank. Yeah, shrank by 2. Okay. This graph does 3 things on number 23. It has a number outside the absolute value, which is telling me it's going up or down. It has a number inside the absolute value, which tells me it's going left or right. And then what does that negative sign in front of it do? But what's it do to the actual V? Nope. What does the negative sign out in front of it do? It flips it, okay? So this is not going to be a V, it's going to be a rooftop. All right, so let's take a look at it. We have negative absolute value of x minus 2 plus 3. Now, the book company is giving you a break here. Look at their x-axis. It goes from negative 2 to 4. So when I'm choosing x values, guess what I'm going to choose? Negative 2 to 4 somewhere. I'm not going to go any further than 4. I'm not going to go any further than negative 2 because they're telling me it's going to fit on this graph. Let's see if it does. So I'm going to do this. I'm going to take the negative 2, the 0, and the 2 that I would normally do because I do a negative number, 0, and then that same positive number. And because they put a 4 on there, I'm thinking in my mind, I might need that 4. So I'm going to go ahead and put it there as well. So now let's just do some substitution. I'm going to put negative 2 in there. What is negative 2 minus 2? Negative 4. What's the absolute value of negative 4? 4. Then I attach a negative sign to it. Negative 4 plus 3 is what? Negative 1. Zero is my friend, except in absolute value. Because I don't have, yeah, what's 0 minus 2? Negative 2. What's the absolute value of negative 2? 2. Put a negative sign on it. What's negative 2 plus 3? What's negative 2 plus 3? 1. Can I tell if it's turned yet? Can't tell in 2 points because it may keep going straight. I don't know. I don't know yet. What's 2 minus 2? 0. There's the 0, my friend, helping out again. Negative 0, blah, 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 blah. What is 0 plus 3? 3. All right. I'm hoping it's turned so far. Nope. It hasn't. It's still a line. So I'm hoping my 4 helps me out. What's 4 minus 2? 2. What's the absolute value of 2? What's the absolute value of 2? 2. Assign the negative sign to it. What's negative 2 plus 3? 1. So that's at 4, 1. Ah, praise hallelujah. Okay, it has turned. And so now I can finish my graph. And I make this gem right here. Oh, that's ugly. Why are you laughing? I haven't seen yours yet. Yeah, big meanie head. Okay, and now let's go to 25. 25 is like what we did for Chapter 3, Section 8, where we are going to create a little graph here. So go ahead and read through 25. Just take a couple seconds to skim over that. What are our 2 things? What are our axes going to be? No, 24. I'm sorry. Did I not tell you to cross off 24? Cross off 24. That's piecewise functions. We don't do those until Algebra 2. Okay, so on number 25, what are our two X and Y axis things? What do we need? Oh, we've had all this time to look at it. Look at us. What's one? Time is one. What's another one? Speed. Okay, so we're going to do time as our x-axis and speed as our y-axis. Okay, so the story is, okay, somebody wakes up and they go jogging at a constant rate. And so constant rate means I'm going to start out with a line. Will we start at 0, 0? Because we would start at 0 time and 0 distance. We haven't done anything yet. As soon as we take that first step, now we're increasing at a constant rate. So there's no set way on how far over you need to go. Just make it constant. It's not a big deal. And then something happens. What does the runner come to in the story? Comes to the road. Okay, so whenever I get to a road, I typically stop, especially if I'm running, which I never run. But if I was, I would stop and see if there are any fast-moving school buses with lots of kids sitting in them that were going to run me over. Yeah, I would want to stop and look both ways. Okay, here's the thing. If I stop, where does my speed go? 0. So I discussed this for those of you in my other classes who are listening right now because I hadn't made a decision. I'm making the decision. What this should do is it should go to 0 immediately. Okay, it doesn't gradually go to 0. You slow to a stop, so you slow down to a stop. Okay, so you're back at 0. Do what? Well, I mean, it's not like a train that it doesn't take you 200 yards to stop. If I'm out running, I don't run fast enough to take 5 seconds to stop. I'm pretty much going to stop on a dime. So we're going to just go with that one. We can have a little bit of leeway, but we're going to go with this one. So in that amount of time, once I stop, okay, then technically I'm going to look both ways, right? I'm not going to stop immediately and then start up immediately again. So my time is still increasing. I'll kind of make that a little bit where it's a little bit bolder. My time is increasing as I'm sitting looking for the car that's going to run me over. And I notice that it's finally not gone. So now I'm going to go back at my constant rate and finish my whatever I'm doing. Okay? So it couldn't be a sudden once we get back down, straight back up, because then that would have given us no time in between our stop and our start. Okay? So here's my little time right here where my time is increasing, but I am standing at the corner of the street at 0 speed. Now, some of you might go, well, Mr. Renault, what if I'm jogging in place? That's still 0 speed. You're not going anywhere. So, I mean, you might still be getting your workout done, and that's fine. But, okay, so I'm going to end that, and then I'm going to ask for questions. So that is the Chapter 3 review.